Now that we have reviewed operations on fractions, let's also review the correct order of operations. In this video, we'll study GEMDAS and absolute value. GEMDAS is a mnemonic device that helps us to remember the correct order of operations. G in GEMDAS stands for grouping symbols. These include parentheses, brackets, curly braces, absolute value bars, and surprisingly enough, even a radical symbol. Now, you may have previously learned GEMDAS as PEMDAS and remembered the phrase, "Please excuse my dear Aunt Sally," where P represents parentheses, but as you can see, there's more grouping symbols than just parentheses to consider. Our next operation, represented by the E, would be exponents. Exponents are pretty easy to recognize, but you also want to realize that a radical can function as an exponent. If you have a set of operations to execute with a radical, first you execute what's under the radical first, as if is in a set of parentheses, and then you can execute the square root or the cube root or whatever root it happens to be. Next up is M and D. This represents multiplication and division. It's important to remember when you're working multiplication and division that you proceed from left to right. And finally, A and S represents addition and subtraction. With this set of operations, again, we will work left to right. So we begin with grouping symbols, proceed to exponents, work the multiplication and division left to right, and the addition and subtraction left to right. Remember that your calculator is programmed with the correct order of operations, so it's a great tool to use to check your arithmetic. Let's apply this hierarchy of operations to example 5. Use the correct order of operations to evaluate the following exactly. Remember when it tells you to evaluate exactly, that simply means don't round your answer. Leave your answer as a reduced improper fraction if necessary. So on all of these examples, we have a variety of operations to execute, and we want to find the exact value of the arithmetic. Before we begin, however, I want to point out an important difference between example A and B that we'll run into quite a bit this semester that is important that you master. So look at the first term on example A and compare it to the first term on example B. Those are going to give us two different answers. If you have a negative that's not included in parentheses with an exponent, then it's important to realize that that exponent only governs the base that's immediately to its left. So we could really think of this problem as -1 times 4 squared. That is -1 times 16 or -16. Whereas if that negative is included in parentheses, then the exponent does have power over the negative. This means -4 times -4 or +16. So watch out for that to pop up a lot this semester. Now back to example A. The first thing that we need to execute is what we have here in parentheses. Now inside parentheses, we have a couple of operations, so we still have to follow the order of operations. Inside parentheses, we'll execute the multiplication before the subtraction. 2 times 5 gives us 10, and then on the next step, we can complete what's inside parentheses with the subtraction. 10 minus 12 gives us -2. Next, we proceed to exponents, and as we discussed before, -4 squared gives us -16, and now that the exponent has been executed, we can go ahead and proceed to multiplication. 3 times -2 gives us -6. Finally, -16 minus 6 gives us our final answer of -22. Now, the good news about arithmetic is if you tend to make mistakes like I do, you can always check this with your calculator. So let's practice typing this in. Notice I'm going to use the little negative at the bottom of the keypad to enter a sign, as opposed to the operation minus, included with the 4 function keys on the right side of the calculator. So I'm going to enter the 4, and then I'm going to square it by typing that x squared button. Plus 3 times, you can open parentheses above the 8, 2 times 5, 5 minus 12, and then close parentheses above the 9. When we press enter, we get negative 22, and looks like we did a good job. Let's try example B. So example B has several grouping symbols, and we want to start with the innermost set first. So I'm not going to execute any of these other operations until I'm finished with the grouping symbols. So I'm not making any changes until I get to the innermost set of grouping symbols. Inside those parentheses, we have to follow the order of operations. We have division and multiplication, but we're going to work those from left to right. So I'm going to begin by executing 8 divided by 2, which gives me 4. On the next step, we're going to work still inside that innermost set of parentheses and execute 4 times 3 to get 12. Now we can work on the brackets. Inside those brackets, we've got, again, a couple of operations. Multiplication is going to take precedence here. 5 times 12 gives me 60, so we have 3 minus 60. And then finally finishing out what's inside brackets. And by the way, I'm going to demote those brackets to parentheses and call that negative 57. All right, we have executed everything we can inside grouping symbols. Next, we proceed to exponents. As we discussed above, the quantity negative 4 squared gives me a positive 16, because that means negative 4 times negative 4, which is positive 16. And then negative 2 times negative 57 gives me a positive 114. 16 plus 114 is 130. Now, that was a lot of operations, so we better check with our calculator. So again, I'm going to type in the original problem exactly as it appears, except for one thing. I'm going to use a double set of parentheses, not brackets. Your calculator will read brackets as a matrix, so if you have embedded grouping symbols, just use all parentheses. And make sure you close the parentheses and close the brackets. And we end up with 130. That's good news. All right, so far so good. Let's go back up here to example C. Now, on example C, notice we do have a radical, and as we discussed previously, a radical can function as a grouping symbol. Essentially, it's grouping together this operation under the radical. So the first thing that I need to do in this problem is execute 25 minus 16. That's going to give me 9. Next, I can proceed to... Actually, let's postpone this multiplication. We'll execute the radical next. So no changes over here. Okay, we executed what was under the radical. Remember, the square root is on the same level of precedence as an exponent. So the next thing I'm going to do is evaluate the square root of 9 to get 3. Okay, that first term has been taken care of. Next, let's work on multiplication. So here we are multiplying 3 fractions together. Before I multiply these numbers together, I want to find common factors and reduce in advance. So here, 24 divided by 4, our common factor there is 4. So 4 divided by 4 is 1, and 24 divided by 4 is 6. Next set of common factors I see here, there's a 5 in the denominator and a 15 in the top right numerator. So 5 divided by 5 is 1, and 15 divided by 5 is 3. Then we have a 3 over 3 there in the end. 3 divided by 3 is 1, and 3 divided by 3 is 1. Awesome! We knocked out a lot of common factors there, so we can now multiply straight across the numerators. In the top, we have remaining 6 times negative 1 times 1. That gives me a negative 6. And notice the only thing left there in the denominator is 1. 1 times 1 times 1 is 1. So we end up with 3 plus negative 6, or you can think of that as 3 minus 6, and that gives us a final answer of negative 3. Okay, let's make sure we know where to find that square root on our calculator. We use the x squared button over here on the left side of our calculator. Notice above the x squared, you have a square root in blue. So to access anything in blue on those buttons, we're first going to type our blue second key, and that allows us to pick up that square root. So I'm going to enter the radicand, 25 minus 16, but I need to use my right arrow key to get out of that radical before I enter the next bit of information. Remember, to get a fraction, we do alpha y equals and choose option number 1. Also notice I'm typing in the original problem exactly as it appears to check our work completely. If you make a mistake at any point with your calculator, you can use those arrow keys to navigate. You also have a delete button up here that you can use to correct mistakes. All right, we came up with -3. That's a good sign. We are doing well. Last example here, we have a fraction. Now, I did mention it earlier, but the fraction bar can also function as a grouping symbol. What I mean by that is before we execute the division that fraction bar represents, we have to execute everything in the numerator and everything in the denominator as if there's a set of parentheses around it. So let's work on that numerator. In the numerator, we have both an exponent and multiplication. So of course we need to do the exponent first. 7 squared is 49, and once that exponent is executed, then we can do the multiplication, -2 times 8, which gives us -16. In the denominator, we begin with the exponent. 2 to the third power is 8, and then on the next step, we'll multiply 3 times 8 to get 24. Okay, again, before we work on that fraction, we need to go ahead and finish the numerator and the denominator. 49 minus 16 on the top gives me 33, and 24 minus 13 on the bottom gives us 11. Our common factor here is 11. 33 divided by 11 is 3. 11 divided by 11 is 1. So it looks like we get a nice clean 3 as our final result. All right, for good measure, let's check with our calculator. So I'm going to start by picking up a fraction, and in the numerator we have 7 squared minus 2 times 8. I'm going to use my down arrow key to get into the denominator and type in the result exactly as it appears. Now, to raise something to the third power, 2 to the third power, I'm going to use my caret key above that divide, type in the exponent, then I'm going to use my right arrow key to get down out of the exponent, and then finish out the entry. Remember, the calculator always gives you the answer in reduced form. So we end up with 3. Now, as we discussed earlier, absolute value bars can also function as grouping symbols. But what exactly is absolute value? The absolute value of a real number A, denoted with the vertical bars, read absolute value of A, is the distance between A and the origin, 0, on the number line. For example, if I look at the number 3 and I measure the distance between 3 and the origin, we would find out that's exactly 3 units. So we say the distance between 3 and the origin, represented by the absolute value of 3, is 3. But also notice, if we look at -3 on the number line and measure its distance to the origin, that distance is also 3 units. The negative associated with that 3 indicates direction. -3 is to the left of 0. But the distance between -3 and the origin is 3 units. So the absolute value of every number turns out to be positive, again, because it represents distance. So on example 6, we want to evaluate exactly the absolute value of -2 to the 4th plus 7 times 2. So we want to think of those absolute value bars as grouping symbols. So we'll execute what's inside absolute value bars before executing the absolute value. Our first item here is -2 to the 4th power. Notice the negative is not included under that exponent because there's no parentheses. So we'll evaluate 2 to the 4th to get 16. and that gives us negative 16. Once the exponent is done, we can execute the multiplication. 7 times 2 gives us 14. Inside absolute value bars, negative 16 plus 4 is negative 2, and the absolute value of negative 2 is positive 2. Let's be sure you know where to find the absolute value bars on your calculator. On the left side of your keypad, you have a button called Math. Choose Math, and then we want at the top, we have a menu. We want to use our right arrow key to highlight NUM for number. And notice option number 1 there is ABS for absolute value. So when you press number 1, that pulls up the absolute value bars on your calculator. Then we can enter our input, negative 2, raised to the 4th power plus 7 times 2. Enter that and we come up with 2. Anytime you have a string of operations, it's always important that you follow the order of operations to get the right value. Be sure to check this work with your calculator to avoid those common little mistakes.